Hi students, today I am going to discuss about motion of a particle along straight line. This kinematics lo one topic. So here you see motion of a particle along straight line. So I am going to give you discuss the problems, main 3-4 questions which includes entire concepts of the topic. So here if you see, imagine there is a car here. Here is a car started at t0. This is t0. And it's moving along the straight road, covers distance s and acquires a speed v in the time of t seconds. After the time t, its speed is v and it has covered s distance. And now the speed of the car is v plus dv. The speed of the car is now little increment in the speed v plus dv in the time of t plus dt, and it has covered the distance of s plus ds. You see this question, this is the entire thing involved in this topic. Say car has started, covers s distance in the time t, acquires the speed v. The speed becomes v plus dv in the time of t plus dt, covers little more distance s plus ds. Now you see the definition of velocity is instantaneous velocity v equal to distance by time. So it has covered the displacement ds in the time dt. So ds is the displacement in the small interval of time dt. So I can say v equal to ds by dt. And increment in velocity, the increase in velocity is dv in the time of dt. So we can define the acceleration as acceleration a equal to increase in velocity by time dv by dt. And from these two equations, if I eliminate, divide these two, dt gets cancelled, a by v equal to dv by ds, means I can get the same equation, a equal to v dv by ds. Eliminate dt gets cancelled. So a by v equal to dv by ds, right? So these are the main three equations of the straight line motion of a particle along the straight line. And from here we know if dy by dx is called the graph, in any graph dy by dx is called slope of the graph. So that I can say here instantaneous velocity equal to the slope of st graph. The slope of st graph. Theory questions important. The slope of st graph is instantaneous velocity, instantaneous speed, and acceleration is slope of vt graph. The slope of vt graph. Important theory question. Sometimes you will be given the slope of vt graph, velocity time graph. Find the slope. That is nothing but acceleration. And here I can say acceleration is nothing but velocity into the slope of vs graph. Instantaneous velocity in the slope of vs graph gives you the acceleration. And moreover I can say from here ds equal to integral of v dt. Nothing but, if I say integral, means you see cross multiply, ds equal to v dt. So integral v dt equal to area under velocity time graph gives the distance covered. Slope, area. You see, whenever we are dealing with the graph related questions, the two important main points, one is slope, other one is area. So the slope of vst graph gives velocity, and here I can say displacement equal to area under velocity graph, area of vt curve. area of velocity, area under velocity time curve gives the displacement. Similarly here I can say cross multiply dv equal to integral of a dt. So here acceleration time graph area under acceleration time graph gives the change in velocity because it is u to v, time varies from 0 to t. See the limits, 0 to t, the velocity varies with u to v, initial speed to final speed. So these are the main points in this graph. Now if the acceleration of the particle is constant, the particle moves under constant acceleration. Remember, this is a condition. Under constant acceleration, I can say a is constant. So in the double integration and we'll get my equations are v is equal, because here v minus u equal to a into t, because a constant. So v equal to u plus at and s equal to ut plus half a t square and v square minus u square equal to 2as. V square minus u square equal to 2as. So these are the three equations valid when the acceleration is constant. If the acceleration is not constant, you go with these three base equations. These three are the base equations. So remember these three relations. So deals with what? UV, AST. These are the main 5 things involved in this straight line along motion of a particle along the straight line. Remember UV, AST called, normally we used to call it as Panchatantra, most important terms. UV, AST, initial speed, velocity after the time t, acceleration, displacement, time. So velocity varies with the time, position with the time, velocity with the position. Remember, because this is not related only with this chapter. The entire mechanics deals with how the velocity of the particle varies with time, how the position varies with time, how the position varies with velocity, velocity, position, time, velocity, position, time, whether the particle moves with a constant acceleration or constant power. In work power energy chapter, constant power we will have the same kind of thing. Our condition is different. Our power constant, not acceleration constant. We will get different equations there. That also I will tell you. Now I am going to discuss the problems. If you want to take the screenshot. So I am going to give you the three questions which involves the entire concepts of this topic. So here, listen the question carefully. Here, listen the question carefully. A car covers, if you want to write down, a car covers 200 meters in the first 2 seconds. 200 meters in the first 2 seconds. T0 to t equal to 2 seconds. 200 meters in the first 2 seconds and 220 meters in the next 2 seconds. It covers, you see, 220 meters in the next 2 seconds, means t equal to 4 seconds. This is the question. See, a car covers 200 meters in the first 2 seconds, 220 meters extra, 20 meters extra in the next 2 seconds. Then find the initial speed u and then acceleration a and then velocity after 7 seconds, 8 seconds, something like that. So in this kind of questions, we have to see, take this point as initial point A, B, C. So remember always to, when you are solving the questions in kinematics or straight line motion of a particle under along a straight line, find out UVAST in the part of journey. So I am going to take the part AB. In my part AB, UVAST. So my initial velocity is U. I don't know which I want to find. Initial velocity is U. I want to get. So the speed is, let it be U. Velocity not required. Acceleration not given. They have not mentioned acceleration. It has covered 200 meters in 2 seconds. 200 meters in 2 seconds. Remember, 200 meters in 2 seconds. I don't know the initial speed. I don't know the VA. So that's all. I can use the relation SC equal to UT plus half A T square. Appliye, I'm going to take the part of BC or AC part. I'm going to take from A to C because the same car. So U is U. V not required. Acceleration I want to find, but I don't know that. See, the distance covered, I am taking 4 seconds. Now I am taking 4 seconds. 4 seconds na. Now I am going to take 4 seconds. 4 seconds let us covered. First 2 seconds 200 meters, next 2 seconds 220. So the total distance will be 420 meters. So 420 meters in 4 seconds, 200 meters in 2 seconds. So I can get SC equal to UT plus half A T square. The relation SC equal to UT, U into 2 plus half A into 2 square. This is my first equation. 2 gets cancelled. And second equation. This is my first equation. And second equation is same. I am going to use 420 meters. So 420 equal to U into 4 because time is 4 seconds plus half A into 4 square. So these are the two equations, two unknowns. You can simplify easily. See here. 2 gets cancelled, so 100. So first equation will be U plus A equal to 100. U plus 2A. Sorry, 2A. See, 2 gets cancelled. 100 times gets cancelled. So first equation will be U plus 2A equal to 100. 1 2 gets cancelled. And 4 gets cancelled. So I'll get 105 equal to U. 4 gets cancelled, U plus 4 gets cancelled. 1 second. 420, 105. So I'll get here half A T square. Sorry, 2 also gets cancelled. 1 second. See my first equation, 1 2 gets cancelled, 1 2 here and here gets cancelled, 2 get common. So U plus A equal to 100 from the first equation, and from the second equation I will get U plus 2A equal to 105. U plus 2 equal to 105. Therefore, I can get A equal to 5 meters per second square, comma U equal to 95 meters per second. So the car has started with 95 meters per second and with acceleration of 5 meters per second square. So this is the meaning of acceleration. First 2 seconds 200 meters, next 2 seconds 220 meters. Extra distance it has covered, means it is accelerating. First 2 seconds 200 meters, next 2 seconds also 200 meters. It is not accelerating, decelerating. It is going with a constant speed. So first 200, suppose if the distance reduced, retarding. So you remember like this. This is the meaning of acceleration. So acceleration means in given interval of time, if the distance covered increases, so it's accelerating. So now I will go to the second question. So if you want to take the snapshot, and second question is, see, you might be showing this. You are driving the scooty. A car covers x distance before its velocity reduces to half. A car covers x distance before its velocity reduces to half. Before its velocity reduces to half. Means you are driving the bike and your car covers, say it has covered x distance before reduces half distance. And my question is, find the further distance it covers before it stops, before it comes to rest. How much distance it covers? This is the question. Again question, a car covers half the x distance before its velocity becomes half. Say 80 kmph becomes 40 kmph in x distance. What is the further distance it covers before it stops? So same UV, AST. I am taking this point as A, this point as B, this point as C. So for AB point, if I take UV, AST, UV, AST. U value I have taken U. I know the final speed is U by 2. I don't know the acceleration. Distance covered is x. Time not required. Any 4 is enough to use the equations. And if I take again the part of AC, see I can take either BC or AC because I know the initial. For BC, initial speed is U by 2. For AC, the initial speed is U. So I am taking BC part, or you can take AC, no issues. I am taking BC part. BC, U, V, A, S, T. My initial speed is U by 2. Distance covered Y. Same car, acceleration is A. Velocity 0 because it stops. Time not required. So if I use this condition here, V square minus U square equal to S. Here velocity with position V square minus U square is equal to AX. V square minus U square equal to X. And here V square minus U square is equal to A because acceleration is same Y. If I simplify these two, I will get Y equal to X by 3 Most important result. This question, and basing on this question you can extend different things. A body projected vertically up with certain speed U becomes U by 2. Half the speed covers a H distance. How much further distance it goes? H by 3. So likewise, you can we analyze this question, most important question, and this question, model of questions related with other things also. Next one, I am going to take third question, which was given in many questions. A car started from rest. A car started from rest here at T0. The car is U0. Car started from rest T0. T0, a car started from rest and it comes to rest after the time T. After the time T, again it comes to rest, stops. In between, some part of the journey it has got accelerated, some part of the journey decelerated. See, it's accelerated for some time with acceleration A equal to alpha. It has got accelerated for some time, I don't know the time. Total journey time is T. Some part of the journey is accelerating with acceleration alpha, and remaining part decelerated with the retardation beta. Means retardation beta means acceleration is minus beta. and find the maximum speed of the car. Maximum speed of the car and the total distance covered by the car. Total distance covered by the car. Remember here again, once again, I am going to explain the question. First, see, you try to develop this habit. Whenever you are solving the physics questions, try to understand the question first. Adliye you will be able to answer maximum part. See, you have started with the car, accelerated for some time, then retarded, finally comes to rest. In between, some part of the journey is accelerated, some part of the journey is decelerated. So, it is the same thing. I am going to take 3 points A, B, C. Kinematics law I want to do like this. For the part of the journey, list out UV, AST. Use the equations. You will get the answer. UV, AST. List out UV, AST. So, for the part of AB, UV, AST. So, U is 0. I want to get V, question mark. A is alpha. Covered distance is X. I want to find this X value. And time I don't know. I am going to take it as T1. Accelerating time is T1. Then I am going for BC. I am not supposed to take AC here, because AB part is with a different acceleration, BC's acceleration is different. Both the parts acceleration is not same. So U, V, A, S, T. U is, my initial speed is V here, acceleration is minus beta, finally rest, and distance covered is Y, time is T minus T dash. Total journey time is T, acceleration time T1 or T dash, whatever it is. T dash. So remaining time is retarding time. So I have listed out. Use the equations. You will get whatever it is. You will get whatever you want. So now I am going to see. So here V equal to U plus AT. V is equal to U0 plus AT. So first equation is V is equal to U plus A T dash. For the first part AB, I have applied the first equation. Now here, final velocity V equal to U is V. Initial speed is V, final speed is 0. Alpha minus beta into T minus T dash. So my first step, from here I can get V value. Eliminate T dash, you will get V value. So that if I solve these two equations, I will get V equal to alpha beta by alpha plus beta into T. Just T dash value substitute here. So automatically I will get V equal to beta into T minus T dash. T dash is V minus alpha. So if I extend this, I will get the result. First equation. Now second part. I want to find the total distance covered. Total distance covered. So adiki, I want to find X plus Y is question mark. X plus Y is question mark. This is the second question. Total distance covered. So for that I want to find X. S equal to UT plus half AT square, or simply V square minus U square equal to 2AS. So V square minus U square is 0 square is 2AX. So I have used V square minus U square 2AS for the part AB. Same for the part BC, V square minus U square equal to A into Y. So I want to get X plus Y. So X plus A is nothing but, see one second, again A is nothing but to A, acceleration is alpha, to alpha into X. So for the part BC, acceleration is minus beta into distance is Y. So clearly I want to get total distance on X plus Y. so that I can get x plus y equal to v square by 2 alpha plus v square by 2 beta, nothing but v square into 1 by 2 alpha plus 1 by 2 beta. Substitute v square here. I'll get the total distance covered is equal to half alpha beta by alpha plus beta into t square. So these three questions covers the entire concepts of the motion of a particle along straight road, and I can solve the same question with the graphs. Means plot velocity time graph. Velocity starts from 0, constantly accelerating, so increases. If I see the graph, VT graph, velocity on y-axis, time on x-axis. Slope of VT graph we know dv by dt, slope and dy by dx. So dv by dt is acceleration, positive, starts from 0, accelerated and then retarded. So here retardation is minus beta, acceleration is minus beta, acceleration is alpha, and maximum velocity is v, journey time is t dash. I have taken the accelerations are not same. That's all. I have taken different slopes. Accelerating means positive slope, decelerating means negative slope. So that's all I have taken negative. May be equal or may not be equal. Total journey time is t here. T 0. This is the time on x-axis. So area if we find, I will get this equation. So these are the main three questions in straight line motion along motion of a particle along the straight road with constant acceleration. My equations are v equal to u plus at, s equal to u plus half at square, v square to 2s. If it is constant power, my equations are different. So a constant power I will take in another class. So and kinematics questions you observe UVAST along different axes, starting point as origin, proceed, automatically you will get the result. Thank you.